All right, ladies and gentlemen, let's take a look at lesson 3.6, using perpendicular and parallel lines. So we're going to construct, we're going to explain what that means. We're actually going to take a look at that in class on Friday, tomorrow, and then use the properties of parallel and perpendicular lines. So a construction is a geometric drawing that uses a limited set of tools, usually a compass and a straight edge. And so that's what we're going to get to use tomorrow. We're going to take a look at how to use that compass and how to actually construct something. So example 1, we're constructing parallel lines. They give you the whole list of directions there. We're actually going to pull this back up tomorrow, and I'm going to show you guys how to construct that and have you guys using some compasses in your note-taking guide tomorrow. So all right, let's take a look at postulate 10. It's the parallel postulate. If there's a line and a point not on the line, so we have a line and a point not on that line, that'll be our point P, then there's exactly one line through the point that is parallel to the given line. So once I put point P in a spot, there's only one line I can draw through it that will be parallel to my given line M. So in symbols, if P is not on L, then there exists a line M through P such that L is parallel to M. That simply means we'll have this unique pair of parallel lines through that point P. The perpendicular postulate. If there is a line and a point not on the line, then there is exactly one line through the point that is perpendicular to the given line. So it's the same thing. Just like through point P, I can only have one line running parallel to L. I can only have one line perpendicular. So there will only exist through point P that is not an L, one line such that L is perpendicular to M. All right. Theorem 3.1. So if we have two lines that are parallel to the same line, then they are parallel to each other. And so what that means is if Q is parallel to R. And so if we look here, we have Q and R being marked as parallel. They have one triangle. And R is parallel to S. And they're being shown as parallel because they have two triangles. So these triangles show which lines are parallel. One triangle will show one pair, two triangles would show a second pair, three triangles would show a third pair. But what we're saying with this theorem is if Q is parallel to R and R is parallel to S, it's kind of like that transitive. Then Q is parallel to S. We can kind of jump all the way through. Because if Q and R is never intersecting, and R and S are never intersecting, then there's no way for Q and S to intersect. So, we look at theorem 3.12. If two lines are perpendicular to the same line, then they are parallel to each other. So if M is perpendicular to P and N is perpendicular to P, if they're both in line P at a 90-degree angle, then we will say M is parallel to N. So that's our theorem. We can look at two lines being perpendicular and concluding that they're to the same line, concluding that they're parallel, or being parallel to the same line and concluding that they are parallel. All right, so we need to do this follow-up after our example in class because it talks about the construction. So once again, just skip over that. All right, and now we're going to look at using the properties of parallel lines. I'm going to need to pause here for the bell. All right, thanks for the pause. All right, let's take a look at how we can use these properties, things that we can do. So in the diagram on the right, each rung of the ladder is parallel to the rung immediately below it. And the bottom rung is parallel to the ground. Explain why the top rung would be considered parallel to the ground. And some of you probably look at this like, well, duh, it is. But these are the concepts that we use in building. If I just make each section as I go parallel to the next, then I know when I get to the end, everything is parallel. And so it does seem like common sense, but they are foundations of what we do. So what we're given, we're told that L is parallel to M. It's parallel to the one immediately below it. And we know M is parallel to N, the one immediately below it. So by the theorem 3.11, if two lines are parallel to each other, are parallel to the same line, then they're parallel to each other. So L is parallel to N. And we know N is parallel to F. It's parallel to this ground. So it would follow that if L is parallel to N and N is parallel to F, then we know L, the top rung, is parallel to F, the ground. And that's all. That's the logic. And so you would explain to me, because in that kind of chain of command, L to M to N, and then N to the ground connects top to ground. All right, now we're going to take a look at these parallel lines. And once again, a lot of times, guys, what we're finding are angle measures. So if we take a look, we're going to find the value of x. We have 2x plus 2, and then we have perpendicular. So by theorem 3.2, A and B will be parallel if line AB and BC are, CD are both perpendicular. All right, to AC. Let me rewrite that a little bit, guys. My handwriting gets a little atrocious. Perpendicular. To AC. So in order for that to be true, this angle BAC, this 2x plus 2, must have a measure of 90 degrees. So since it must be 90 degrees, set it equal to 90. Subtract the 2 from each side, and then divide each side by 2. X must be 44. So explain why A is parallel to C. I want you guys to do now, but what I want you to do is name the theorem. Put slash postulate. You should be able to look back at those diagrams, look back at those, look at the theorem, write that theorem down, and then reread it. So I want you guys to do that for number 1. Okay? For number 2, we're going to do that. What value of x would make lines DE parallel? In order to be parallel, that means these have to be perpendicular to the same line. So that means I want 5x plus 10 to equal 90 degrees, because if one angle is 90 degrees, that means all 4 of them around here should be 90 degrees. So I'm going to take 5x plus 10 and set it equal to 90. 5x is equal to 80 when I subtract the 10. And when I divide by 5, I get x is equal to 16. Guys, they kind of give you a nice wrap-up of showing ways that lines are parallel to each other. We looked at 3.5, the converse of the corresponding angles. So if I show that a pair of angles, corresponding angles are congruent. So if I can find an x value that would make those angles congruent to each other, then they are parallel. If I can have my alternate interior angles being congruent, then that would mean my lines are parallel. My alternate interior, alternate exterior angle converse, to show a pair of alternate interior angles are congruent. So if my alternate exterior angles are congruent, and my same side, SSS, my same side interiors angles must be supplementary. So those are the 4 ways that we used yesterday in lesson 3.5. If we take it the new way, to show that 2 lines are parallel, to show both lines are parallel to a third line. Okay, so because we have this line being parallel to this line, and we have this line being parallel to this line again, that means green is parallel to our blue line. And then if you're in a plane, show that both lines are perpendicular to a third line. And so because both of these lines are perpendicular, that means I could say that they are parallel. All right, we'll work on using those tomorrow in class.